So for this first exercise, you're going to take the straws and in those combinations on your warm-up sheet, you're going to try to make triangles and just indicate if you can or cannot make triangles out of those colored straws.
One yellow, two yellows and a blue. Yes, I can. Just like that. I'm a perfectionist, so it's not quite perfect, but I'm satisfied.
It's straws. It will be okay.
So
You
just
remember.
put, yes on here, is that
Correct.
what we're looking for?
Yes or no. And remember, if this was a real line, lines don't have any dimensions. These straws have dimensions, so it's a little hard to get them together perfect. So don't let the perfectionist thing interfere with you. Just pretend they're flat lines, even though they're not.
As a young child, I do find it discouraging, however.
Really?
A yellow, a blue,
This
and a
would bother
green.
you if you'd had this as a child?
Probably.
Ah.
Is a triangle possible with a yellow, a blue, and a green? Well, no, because the yellow one's too long.
The yellow one's too long,
I don't think I can quite pull it off. It doesn't reach to the point.
so you're not able to make a triangle out of that one. And as you stated, the yellow one's too long.
Yeah.
So what does that give you some idea on the what you would need for it to work?
A pair of scissors.
Well, that would be one approach. However, without cutting it, you would need maybe a triangle, all your triangle pieces, the other two triangle pieces to be longer than that yellow one, huh?
That is also an alternative solution, not one that I would choose though. I'm fresh out of straw stretchers.
Okay. So what is your answer to that warm-up question?
I'm gonna put no.
All right.
A yellow and two greens. Maybe. Let's see what we got here. What are the dimensions of this?
Well, we're not worried about the specific dimensions for this. We'll have some actual measurements in some of the later assignments.
I'm gonna go with no, because they're equal lengths at this point.
That is correct. And do you remember from earlier lessons what equal lengths, like when they're just together like that, and again, pretend they didn't have any dimensions, what would that be?
Parallel lines.
Well, in this case, it's going to be a straight line. If you had where you put it all the way together, because they're the same length, and they would be like right on top of one another. But that is another concept, the parallel lines. It's good that you thought of that.
A yellow, a green.
Also a straight angle.
Orange, no. Isn't a straight angle a contradiction in terms?
No, it's an actual geometric term.
I haven't done this.
It's 180 degrees, or a straight line would be a straight angle.
I haven't done this in 35 years. So, are you filming me right now?
Yes.
All right. All right. No. Two yellows and an orange. The quick answer to that one is yes. That's easy. There
All
we
right.
go.
Very good.
Thank you, Miss Jennifer.
So we're going to take a few minutes and go over those other questions.
Which triangles could not be assembled? That's 2, 3, and 4. Find the sum of the lengths of the B and C side.
In class, we would have a ruler to measure that and do that, and I don't have a ruler right now. And before you do that, though, here is something with measurements. We have a website here. In this website, you can adjust the triangles. Now, if we were in a classroom, I would have the iPads passed out now so people could play with this a little bit on their own and see. But remember, you were saying that your two lengths weren't enough, that the yellow was bigger on the one, and the other comment about how the one was a straight line. You can play with this and you can see the different line segments and how their values change and what the total is. And so playing with that a little bit, it will explain this concept of the triangle inequality theorem.
Is the concept here that these are lengths, or I guess
Yeah,
some
they
are
all,
not
you can all
degrees?
adjust all of them. You can move the points and adjust it, but in here it gives you what the measures are. Kind of like your question number 2 there was, that you would be doing with a ruler.
Right. So the sum of the two has to be greater than 30, the longest one.
Right, and this 30 you can
particular
change to.
one. Yeah, in this
Yeah,
particular
in this
one.
particular triangle.
I'm just using it as a baseline, so it's a nice round number.
But you can change it for any size triangle, and that rule is going to stay the same. The triangle inequality theorem states that any side of a triangle is always shorter than the sum of the other two sides. So playing with that, and I would give students a while on their iPad to see what kind of different shapes they could make and stuff. Playing with that, you can get a good idea of that.